dears, this is Raji. Related to analytical chemistry, we had discussed a super easy trick to identify the presence of a cation in a particular salt solution, and also we had discussed how to detect the presence of a gas which is produced as a result of a chemical reaction. In this video, we are going to learn how to detect the presence of an anion that is present in a salt solution. If you are learning this concept also, you will be able to answer a number of questions from analytical chemistry chapter, and I have kept a number of board questions also at the end of this video. We will discuss that also. Now see this picture. In order to identify the presence of an anion, we will be generally using three methods. Carbonate, sulphite and sulphide can be identified using dilute sulfuric acid. Chloride and nitrate can be identified using concentrated sulfuric acid. But if any sulfate is present in a particular salt solution, you cannot use concentrated sulfuric acid or dilute sulfuric acid also. So in that case, how to detect the presence of sulfate? Everything we are going to learn in detail. Suppose you are provided with a salt solution and you are going to detect the presence of carbonate in that. Actually, it is sodium carbonate solution, but we don't know that. So, in order to detect the presence of a carbonate in that, what we will do? Had better add dilute H2SO4 solution into that. Okay. So, what will happen? Whenever a dilute acid is reacting with a carbonate, okay, how to predict the product of the reaction? Definitely, one product obtained will be carbon dioxide, another product obtained will be water. Along with that, you will be getting a salt also. So, sodium sulphate is a soluble substance. You can't observe any color change or something. But what you can observe, you can see a colorless, odorless gas that will be evolving out of the test tube. Okay, in order to confirm that whether the gas evolved is carbon dioxide, we will pass it through lime water. What is lime water? Lime water is calcium hydroxide. If you are passing carbon dioxide through that, what will happen to that? It will be turning milky. Why the milkiness is happening? Due to the formation of calcium carbonate. In the previous video, we had discussed how to identify the presence of a gas. You should definitely go through that. Okay, so that it will become more easy for you. Got it, no? So, in order to detect the presence of a carbonate, we are using dilute sulfuric acid. So, after adding dilute sulfuric acid, if the gas evolved is carbon dioxide, definitely we are confirming that, the anion present in the solution is carbonate. What is that? That is CO3 2 minus you should write. Got it? Now, we are going to detect the presence of sulphite ion in the salt solution. What is the formula for sulphite? SO3 2 minus. You should remember that. So, you have provided with sodium sulphide solution, but we don't know that whether sulphite is present in that. It is a clear solution, right? To that, we are just adding dilute H2SO4. Whenever we are adding a dilute acid into a sulphide, what will be the expected product obtained? You will be getting definitely sulfur dioxide as one product and water as another product. Along with that, what will happen? A salt also will be formed. Okay, that will be Na2SO4. Correct, no? Sodium sulphate is a soluble substance. Remember, all sodium salts are soluble. So, you can't observe sodium sulphate. But what you can observe? You can observe a colorless gas with a burning sulfur smell or having a pungent smell will be evolving out of the test tube. And how can you confirm that whether the gas evolved is sulfur dioxide? Pass it through acidified potassium dichromate solution. Then what will be the observation? We had discussed it already. It will be turning into clear green. Okay, so that confirms the presence of sulfur dioxide gas. Otherwise, what you can do? Pass the gas through acidified KMnO4 solution. So, what will happen to the color of KMnO4 solution? It will become colorless. Okay, these two tests indicates the presence of sulfur dioxide. But remember one more point. Okay, if you are passing sulfur dioxide gas through lime water, what will happen? Lime water is calcium hydroxide. Okay, so both of it will react together to form calcium sulphide. Along with that, little bit of water will be forming. So calcium sulphide is also a white precipitate. You should remember that. So carbon dioxide also, sulfur dioxide also will give milkiness with lime water. You should remember that point. They will ask you. Now we are going to identify the presence of sulphide ion in a salt solution. S2 minus ion. Okay, yeah. So what is the formula for sodium sulphide? Na2S. But we don't know that, okay, whether the sulphide is present in the salt solution. So how can we test it? We will add dilute H2SO4 into that. So what will be the reaction? Whenever a dilute acid is added to sulphide, what will happen? Definitely, one product obtained will be hydrogen sulphide and another product obtained will be one salt, that is sodium sulphate. Correct, no? Yeah. So sodium sulphate will remain in the solution only. You can't observe it because all sodium salts are soluble. But hydrogen sulphide gas you can observe. So how can you identify the presence of hydrogen sulphide gas? It is a colorless gas having the smell of rotten egg. If you are passing this hydrogen sulphide gas through lead acetate solution, what will happen? Yeah, the color of the solution will be turning silvery grey. Okay, that will be the observation. In the last video also we had discussed about it. Okay, yeah. Why it is turning silvery grey? It is due to the formation of lead sulphide. This is a confirmatory test for hydrogen sulphide. So, while adding an acid to a particular salt, if the gas evolved is hydrogen sulphide, definitely the salt will be containing sulphide ion, S2 minus ion. We will confirm that. So the presence of carbonate, sulphite and sulphide we detected using dilute H2SO4. Whenever a carbonate ion is present in the salt solution and if you are adding H2SO4, what will happen? Carbon dioxide gas will be evolved. Whenever you are adding dilute H2SO4 into a solution containing sulphide, it will be producing sulfur dioxide gas. You can detect it easily. And if S2 minus ion is present, yeah, definitely you can see the evolution of hydrogen sulphide gas if you are adding dilute H2SO4 into that. Clear? Now we are going to detect the presence of chloride. Yeah, it can be detected by adding concentrated H2SO4 only. Why? We are going to see that. Now see this one, we are going to detect the presence of a chloride in a particular salt. So you have provided with sodium chloride. We know that it is a white colored substance. We need to check whether chloride ion or Cl minus ion is present in that. Sodium chloride will not react with dilute H2SO4. So you will have to add concentrated sulfuric acid into sodium chloride. We are slowly heating the test tube so that the temperature will not exceed above 200 degrees Celsius. Okay, yeah. So what will be the product of the reaction? You are learning the same reaction in hydrogen chloride chapter also. You will be getting NaHSO4. Along with that, one more gas will be evolved, which is that is hydrogen chloride. If the gas evolved is hydrogen chloride, how can you detect it? You learned that a glass rod dipped in ammonium hydroxide will be brought near the mouth of the test tube. So what will happen? Ammonium hydroxide and hydrogen chloride will react together to form dense white fumes of ammonium chloride. While adding concentrated H2SO4 to a particular salt, if the gas evolved is hydrogen chloride, definitely we can confirm that the salt will be containing chloride ion. This is a confirmatory test for chloride. Got it? Okay. Now, one more way they will be asking the question. When we were adding concentrated H2SO4 to sodium chloride, it was in the solid state. Now, if a chloride ion is present in the aqueous solution, how can you detect the presence of chloride ion? One more test is there. You add silver nitrate solution into that. So, what will be the reaction taking place? NaCl plus AgNO3. Right, and see, you will be getting NaNO3. All sodium salts are soluble. Along with that, you will be getting a white precipitate of silver chloride. There is something special about silver chloride. Silver chloride is a white precipitate that is soluble in excess of ammonium hydroxide. So this part you should remember it. It is very important. Got it, no? So what will be the observation of the reaction when an aqueous solution of chloride is reacting with silver nitrate solution? You can see a curdy white precipitate that will be soluble in excess of ammonium hydroxide. So you should remember the picture and you should memorize the concept also. Got it? How to test the presence of nitrate and sulphate we will discuss in the next video. But you will be able to answer all this question. This is related to what we have discussed now. Okay, just read and find out. Identify the anion in each of the following compounds. Addition of dilute hydrochloric acid to B produces a gas, which turns lead acetate paper silvery black. So lead acetate paper is turning black. So that means, which gas it should be? We know that is hydrogen sulphide. Okay. If dilute acid is added to something, it is producing hydrogen sulphide gas. So this salt will be containing which anion they are asking. So how you will write? It should be either sodium sulphide, iron sulphide or potassium sulphide. But the anion present in that should be S2 minus ion. This is sulphide. Got it? You should write it like that. Got the answer. Now see this one. When dilute sulfuric acid is added to D, a gas is produced which turns acidified potassium dichromate solution orange to green. From the observation, can you identify what is a gas present? That will be sulfur dioxide. Whenever we were adding a dilute acid to a particular salt, sulfur dioxide gas is evolving out. So, can you identify which salt it should be, or this salt will be containing which anion? It should be containing sulphite ion, SO3 2 minus. You should write sulphite, ITE you should write. Got it? So easy. Read the next one. Addition of dilute hydrochloric acid to E produces effervescence. Okay. And the gas produced turns lime water milky but does not have effect on acidified potassium dichromate solution. So we can confirm that which is that gas? You will be knowing that is carbon dioxide. So whenever we are adding dilute acid to something, carbon dioxide is evolving out. If so, this salt will be containing which anion? It should be containing CO3 2 minus ion, or you should write carbonate. Easy. Got it. Now read the next one. When a solution of compound B is made to react with silver nitrate solution, a white precipitate is formed which is soluble in excess of ammonium hydroxide solution. This is a famous question and I told you to memorize also. You will be remembering. Okay, So to the compound B, when we are adding silver nitrate solution, you are getting a white precipitate. And how to identify that white precipitate? If a white precipitate is soluble in excess of ammonium hydroxide, it will be silver chloride. Okay. So silver nitrate is reacting with something to form silver chloride. So which will be the anion present? It should be chloride ion. Cl minus ion or chloride you should write. That is the answer. Got it? Easy. Now see this question. Identify the anion present in each of the following compounds. Same way they are asking. A salt M on treatment with concentrated sulfuric acid produces a gas which fumes in moisture and gives dense white fumes with ammonia. So by this statement itself we will come to know that, which is that gas? If it is producing dense white fumes with ammonia, the gas will be hydrogen chloride. But they are not asking that, from which salt it is produced? So that will be either sodium chloride, potassium chloride, So the anion present will be chloride you should write. Got it? Now see the next one. A salt D on treatment with dilute sulfuric acid produces a gas which turns lime water milky but has no effect on acidified potassium dichromate solution. So can you identify the gas? It will be carbon dioxide. But after adding dilute sulfuric acid only, carbon dioxide is evolving out of the test tube. So D will be containing a carbonate. So how to write the answer? It should be CO3 2 minus, or you should write carbonate. This is the anion present in that. Easy. One more point to be remembered. Hydrogen chloride gas is highly soluble in water. So hydrogen chloride, when it comes in contact with atmospheric moisture, so it will be getting converted into misty droplets of hydrochloric acid. Correct? So we feel that this gas is fuming in atmosphere. Correct? So you should remember that also. So which gas fumes in moisture, they will ask you. Another question. So that time, we should remember it as hydrogen chloride gas. That also we got it. Now see this question. State your observation in each of the following cases. When dilute hydrochloric acid is added to sodium carbonate crystals, what will be the observation they are asking? So we don't want to write the balanced chemical equation, but yeah, you just write and see. When dilute hydrochloric acid is added to a carbonate, definitely one product obtained will be carbon dioxide. Another product obtained will be water. Along with that, you will be getting a salt also. In this case, it will be sodium chloride. What will be the observation? A colorless, odorless gas will be evolving out of the test tube, which when passed through lime water, it will be turning milky. Okay, you can just remember like that. Now see the next one. Carbon dioxide and sulfur dioxide gas can be distinguished by. So lime water, acidified potassium dichromate paper and other options are also given. Which is the answer? Yeah, we already discussed that. Okay, carbon dioxide when passed through lime water will be giving milkiness of calcium carbonate. Sulfur dioxide when passed through lime water, it will be giving milkiness due to calcium sulphite. Both carbon dioxide and sulfur dioxide will be giving milkiness with lime water, so it cannot be identified using lime water. Okay, both are acidic gases. It cannot be identified using litmus paper also. But sulfur dioxide will be giving a positive test with potassium dichromate paper. Potassium dichromate paper will be turning from orange to pale green. Right now, when sulfur dioxide is coming in contact with it, whereas carbon dioxide will not answer that. So which is answer? C. Acidified potassium dichromate. Got it? Now see the last one. When a solution of compound B is made to react with silver nitrate solution AgNO3, a white precipitate is formed which is soluble in excess of ammonium hydroxide solution. If you are getting questions repeatedly like this, you will be memorizing the concept also. Which is that white precipitate that is soluble in excess of ammonium hydroxide? That is silver chloride. So, silver nitrate is reacting with something to produce silver chloride. So, definitely, the compound will be a solution of chloride. So, compound they are asking, not the anion. So, you can write, any soluble solution of chloride. So, that will be sodium chloride. Got it? That's the answer. So, we have discussed so many questions related to the identification of anion. We will be discussing the identification of nitrate and sulfate in the next video. Hope you might have understood the concept. You keep on working